Hello everyone. In today's video, we are going to learn how to value the European options using Black and Scholes model. For this purpose, we are using an exemplary academic question. This question is stated as follows. Consider a put option on a non-dividend paying stock when the stock price is $40, the strike price is $42, the risk-free rate of interest is 2%, the volatility is 25% per annum, and the time to maturity is 3 months. And we have to calculate the price of a European put option first and the price of a European call option. Let's talk about each variable first. So this $40, this is a current stock price. Strike price, which means an option holder will have an option to exercise its put option at this price. Because it's a put option, so option holder will only exercise the option if the stock price in the 3 months' time will be less than the strike price. On the other hand, if it's a call option, an option holder will only exercise the option if the stock price will be higher than the strike price. Other than that, if it's not the case, the option holder will let the option expire. Now let's identify each of those variables. So your current stock price is denoted by S0, which is $40. The strike price is 42, and your risk-free rate is 0.02%. 2% can also be written as 0.02. What does it mean by volatility? Volatility means there is a risk of 25% that the stock price can vary in either direction. As we can see, the time of the maturity is 3 months. This means the option will expire in 3 months' time. So the volatility, you can write it as 0.25. When it comes to the time, it should be noted that the maturity is given in months. So if it's given in months, you have to change it into year by dividing by the number of months in a year. So this will give you 0.25 years. Right? I have already solved that problem for the purpose of making this video as short as possible. So let's go through the solutions together. On the right side here, you can see the formulas for Black and Scholes European option with no dividend. So this is the formula I'm using for call option, and this is the formula given for put option. We have all the given variables except the value of D, D1 and the value of D2. And we have the formulas given for to find the value of D1 and value of D2. In the first step, we will calculate the value of D1 and D2 using these formulas. I have copied these formulas here to make it more visible. To calculate the D1, we will insert the values we have been given in the question. So replacing the values S0, which is your current stock price, 40, and divided by the strike price, which is 42, plus the risk-free rate, 0.02, plus the volatility, which is sigma, 0.25, raised the power 2, which means you have to square it, and divide it by 2. Multiply by its time, 0.25, which is 3 by 12. Divided by the volatility is 0.25, the square root of 0.25, and that gives you the value of D1, which is negative 0.2878. Make sure to note your answer up to 4 decimal places. Once you get the value of D1, you apply that formula to find the value of D2. Placing the value of D1 minus 0.2878 minus your volatility 0.25 and the square root of time 0.25, and that gives you the value of D2 minus 0.4128. Once we get the values of D1 and D2, we plug in these values back into the formula of the put option. As we can see from the formula, there's a minus sign with D2 and D1. So the negative values and the minus in the formula will make the values positive. In the next step, now we have to calculate the normal distribution probabilities of these two numbers. Since the values of D1 and D2 are more than 2 decimal places, so in that case, we use the interpolation formula. If we had these values up to just 2 decimal places, we could straight away just find the probabilities using the probability table. Since these values are more than 2 numbers, more than 2 integers, we have to use the interpolation formula. Now have a look how we can apply the interpolation formula. So, applying the formula, we first have to make combinations of these 4 numbers. So we will say let A equals the normal distribution of the first 2 numbers after the decimal, 0.28, and B equals the first number and the third number, the combination of first number and the third number. We will skip the middle number, so it will be 0.27, and the C equals the last 2 digits, 0.78. Remember, you just need to find the probability of the combination of first 2 numbers and the combination of first and third number. For the C, we don't have to find any probability. We also have to make sure that in the formula, the difference would be calculated from the bigger number minus the smaller number. So in that case, A is the bigger number comparing to the number of B. And because the value of D is positive, therefore we will use positive sign in the formula. So your formula will become like the normal distribution of A plus C, open the brackets, and the difference between normal distribution of A minus the normal distribution of B. We plug in all these values, right? And then next step is to find the normal distribution, the probability of normal distribution from the table. Let's have a look onto the table and find the probabilities of 0.28 and the probability of 0.27. This is being repeated here. So let's find the probability of 0.28 and the probability of 0.27. So this is the normal distribution table. We have to look into this column and this row. 0.2 and then go up to 8. So that makes it 0.28. So the probability is 0.6103. And for 0.27, the probability is 0.6064. Take these values and plug into the formula. 0.6103 plus 0.78, which is just your C, and this number is being repeated here, minus 0.6064. This is the probability you found for 0.27. Calculate this formula and you will find the probability, the total probability of that value, which is 0.6133. You can double check your answer by using your Excel function. Equals norm dist, which is normal distribution 0.2878, and that's equal to this value, which means your answer is correct. Now apply the same principle onto the next number, the value of D2. So the value of D2 is 0.4128. So then we combine that. Make the combinations of these number. Let A equal 0.41, the first two numbers, and the B equals the first number and the third number, 0.42. And the C is the last two numbers. C equals 0.28. I forgot to put normal distribution sign with that. And then you also have to make sure the difference is supposed to be from the big number minus the small number. So in that case, your formula will be NA plus C NB, because NB is the bigger number comparing to A. B minus NA. And then find the probabilities of 0.41 and 0.42. Looking back into the table, 0.41, which is 0.6591, and 0.42, the probability is 0.6628. Insert these values into the formula, and then you calculate the total distribution, total probability of that number, double checking that number using the Excel function. .4128. Yes, this is exactly the same number. Now, once you got the probabilities of D values, now you plug in these values back into the formula. So I remind you the formula. We have this formula. I have already copied it down here. So you plug in these values, which is the probability of ND2 and the probability of ND1. Calculate these values using your calculator and you find the value of a put option, which is 3.055. Now, applying the same procedure to calculate the value of a call option. So as you can see, the value of a call option, we have all the given variables except for the normal distribution of D1 and the normal distribution of D2. The values of D1 and D2 are positive in this formula, and the calculated values of D1 and D2 are negative. So once you place these values in that formula, the values will be negative. So let's have a look how we calculate that. So I have inserted the values of D1 and D2 into the formula above for the call option. Now the next step is to find the normal distribution probabilities on these values. And remember, these are now negative values. We apply the interpolation formula again by using the combinations. So let A equals the first two numbers minus 0.28 And then b equals the combination of first number and the third number. So that will be minus 0.27. And the c equals 0.78. Now remember, we have to choose the biggest number, greater value. So when it's a negative number, the smallest value with negative is considered the greater value. So in that case, your formula, because the b is greater than the value of a, then your formula will become normal distribution of minus 2878 equals normal distribution of a minus c and normal distribution of b minus NA, because B value is greater than NA. Now going back to the table and find the probabilities of 0.28, minus 0.28, and minus 0.27. So this is the minus table here. So minus 0.28 is 0.3897 and minus 0.27, the probability is 0.3936. Placing these values in the interpolation formula, we get our answer 0.3867. This is the total probability on the value of D1. Now let's double check that value using the Excel function. Norms dist equals negative 0.2878. Yes, your answer is correct. 0.3867. Apply the same procedure for finding the normal distribution on D2, on the value of D2. Let's apply the combination 0.41, negative 0.41, and the B is negative 0.42, first number and the third number. And then C equals the last two numbers, 0.28. Make sure you plug in the negative number here. So in the formula, applying that, so again, you have to make sure you know which one is your greater number. The number with the smallest value with negative sign is considered greater number and comparing to the other number. So 41 is the greater number comparing to this B. That's why the value of NA will come first. Therefore, you apply this formula and go and check your probabilities from the table. So negative 41, 0.3409, and negative 42, 0.3372. Applying these probabilities here, and you get the total probability 0.3399. Double checking that values from the Excel function, negative 0.4128. Your answer is correct. Now, once you have the values, probabilities of normal distributed, once you have the normal distributed probabilities, place these values into the call option formula and you get your value of call option. I hope this video is useful for all of you. Thank you.